we will look at some more examples, I suppose. Do you guys have any questions about any problems in particular? Maybe? Maybe? Not sure? Do you remember the kind of sort of problem it was? Was it something like, I guess it was about factoring probably. Did it have P's and Q's in it?
Yes, it had Q's in it.
P's and Q's. Was it P squared Q squared minus 25?
It was some problems similar to that.
Okay. So here's one. This is section, probably section 4.4. So section 4.4, number 41. Here we're asked to factor P squared Q squared minus 25. So a lot of these problems, the critical idea that we must remember, right, is this. A squared minus B squared is A minus B times A plus B, right? So if we can look at a problem as the difference of squares, then we can factor it, you know? So this one, see P squared Q squared, that's really the same as P times Q squared, right? Like this is I can rewrite that as this, right? This is PQ. So if I multiply PQ times PQ, how does that work? If you doubt me, here's the details, right? This is PQ, PQ, right? So that's PP, QQ, which is P squared Q squared, yeah? So this is just laws of exponents, gives me that. And this is 25. Well, 25 is 5 squared, yeah? So something like this, I go, oh, well, difference of squares, right? Where A is equal to PQ and B is equal to 5. So I do PQ minus 5, PQ plus 5. And that's it. For that one, yeah. Let me see if I can find another one with P's and Q's. Here, this one's a little this one, now maybe this one's the one you got stuck on. This one's kind of tricky. Number 60. I'm not sure I know how to do this one right offhand. I mean, I do because I got the answers in this book, but that's kind of cheating, isn't it?
When did you say our
Next test is next Friday, yeah.
is it going to be on you?
Yep. Next test is on chapter 4. 25Q plus 3P squared minus 75. Now, I mean, these problems, you want to understand them, right? But these kind of PQ problems, that's like, at most 10% of the test. The bigger thing is the problems I'll work after this. But sure.
Okay, so I gotta catch up on my homework, but is that grade gonna be like at the end of the semester, or like you put it in as you go?
Oh, no, I put the homework grade in at the end of the semester.
Okay.
Yeah.
I gotta catch up.
Yeah, so as long as you finish the homework by the end of the semester, you should be okay. But you really want to finish the homework before the test, otherwise it doesn't help you, And even more important than that, you want to make sure you work through the review sheet carefully, right? Because what tends to happen is our test is like half of the review sheet, right? Kind of pick from the review sheet.
I'm not missing no more days either.
Not missing more days. One day at a time, right? One day at a time.
My advisor already read me to the field.
Goodness, I look at this, right? And I'm like, what can this is a factor. This is one of those factoring by grouping problems we talked about last time. It's one of those. So look here. So this one and this one, they both got a p squared. So those go together. So let's start with that. P squared times what? P squared times q plus 3. Now, these two terms then, maybe I can combine these. Can I combine these? I got 25 and a 75, right? Mm-hmm. So 75 is 3 times 25, right? So I can factor out a 25 from these. I can say like minus 25. And so that gives me q from the first one. And plus 3, right? So if you're stuck on the one in the homework that's like this, I completely respect that. I think this one's tricky, yeah? But once you do that, now we've got a common factor, right? I've got q plus 3 and q plus 3 on both, so I can factor the q plus 3 out using the distributive property. See, this is p squared minus 25 times q plus 3. Am I done? Well, I'm not done yet, right? I can do a little bit better. See, because p squared minus 25 is really the difference of squares again, right? Right, so this we can factor into p minus 5 times p plus 5. Once you've got all linear factors, you're done. You can't go farther than that. So, did you find the problem, or does this feel like it?
Yeah, this is similar to what I was looking on.
Well, I'll tell you what. You go back to your homework, and then you come back Friday, and tell me which one when it is Friday. We'll look at it, okay? So, most likely. So while we're on this, let's look at number 100 from this section. Number 100 is p to the 6th minus q to the 6th. So we did one kind of like this last class, but with the 8th power, remember? Now we got the 6th power, right? So what we can do is we can look at this as p cubed squared minus q cubed squared. Now I have the difference of squares. So I'm thinking a equals to p cubed and b equals to q cubed. It's a squared minus b squared. That's the pattern. So I use my difference of squares formula. I got p cubed minus q cubed times p cubed plus q cubed. Now, something I should mention is that there is yet another special formula we know for cubes. So this is the difference of squares. There's a difference of cubes formula. It looks like this. What's the difference of cubes formula? Difference of cubes formula is this. A cubed minus b cubed is a minus b. And then I got to put an a squared here. And I got to put a b squared over there if you think about it, right? So whatever I put here, when I multiply it out, I got to get back there, right? So a times a squared gives me a cubed. Minus b times b squared gives me minus b cubed, right? And whatever I put in the middle here, it's got to be such that all that junk cancels out. I'm going to try plus ab, see if it works. Let's see here. So if I put plus ab there, right, what happens is I get plus a squared b, right? But there's also a minus a squared b, so those cancel, right? And there's also a minus ab squared, which cancels with the plus ab squared. So this is 2 things times 3 things. There's 6 total things, but 2 pairs of those cancel, which just leaves you with these 2 things. Anyway, this is an identity which is known, so you can memorize it. You know, let's see here. Did I allow you guys to have a sheet of notes for the test? No, I did not. Okay, I should stick with that. How about this? I think for the next test, because if just in case there's a problem that involves this, you can have a 3-inch by 5-inch card for the next test. If that'd be helpful to you. So you can put some formulas on that if you want. That way, a 3-inch by 5-inch card, that's enough to put a couple formulas on, but it's not so much that, you know, you don't get, hopefully you don't get too much of a sense of this is going to get me out of all my troubles. That's the trouble. Is I've been giving students formula sheets on tests lately, and they get it in their head like, oh, I got this formula sheet, so I'm safe. Well, writing something on the formula sheet doesn't mean that you can do the problem, right? Yeah. Anyway, so I will allow a 3 by 5-inch card, okay? So a cubed, this is the other one, a cubed plus b cubed. So this time, again, we put a plus b this time. I still got to put an a squared here. Still got to put a b squared over there. But check it out. Now, I have to put minus ab in the middle. Because to multiply it out, I get ab squared, ba squared minus ba squared. And then I get a, let's see here, ab squared. Wait a minute. Should it? I got my b cubed. I got my b cubed. I got my ba squared minus ab squared, yeah. And ab squared. Oh, minus ab squared. Yeah, it's good. It's good. We're fine. We're fine. You can actually get the second identity from the first by just substituting like minus b for b. Like check this out. If you did, well, let me not do that. Let me shut up. Focus here. So these are 2 identities that we know that people know. Now you know them. Well, anyway, you've been told them. So that's a step on the road to knowing them. So what that means is we can take this difference of cubes, or the sum of cubes, and simplify it. See, that's actually going to be p minus q times p squared plus pq plus q squared. And this is going to be p plus q times p squared minus pq plus q squared. So yeah. Now, if I had this problem on a test and I said factor p to the 6th minus q to the 6th, right? I would be content. I would be, in fact, overjoyed if I had the students just do this much, right? if you got to the blue one, that'd be like bonus points, right? That's fancy. All right, let me go. Excuse me. Look at some section 4.8 problems, okay? So these ones are about solving equations, all right? So let's look at that. I seem to have lost my, I guess I can make do with an eraser. I kind of want my, no, I need my eraser shirt. Just a second here. Do, 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 do. I shouldn't have erased that. A cubed minus b cubed. That thing's always, should always be at the ready. That's always coming up. Okay, so let's look at some factoring problems that are a little bit more sort of down the middle. So let's say factor completely. Over the real numbers, okay? Example 1. Let's try to factor x squared plus 3x minus 28, right? Example 2. We're going to work on factoring x squared plus 20x plus 100. Example 3. We're going to factor x squared plus 8x. Example 4. We're going to factor 9y squared plus 15y plus 4. All right. There's what we got in front of us, okay? Let's look at these problems. So can you guys help me out? What am I going to do on example 1 here? So what's our game plan? Our game plan is to try to use the guess and check, right? If that blows up in our face, then we fall back on completing the square. That's my method. So we'll make a template. We got x, right? So what 28? How did we get 28? What is 20? You say 4 and 7? One of them's got to be negative, right? Though which negative 4 plus 7? Now is that right? Well, minus 4 times 7 is minus 28, and this gives me minus 4x, right? And that gives me plus 7x. 7 minus 4 is 3x. Hooray. There we go. Done. Factored. How about this one? I'll start out with the... You don't even need to think about that, right? You just do that, write it down, and then try to fill it out, right? How do I get 100? A lot of different ways, right? 1 times 100, 2 times 50, 4 times 25, 5 times 20, you know? What else? 100 is such an interesting number, isn't it? There's a lot of ways to factor it. I need whatever factors I pick of 100, right? I need the sum of those factors to be 20. What should I do? 10 and 10. What do you think, McKay? Is that good? So again, to check our answer, we have to think about the cross terms, right? So like 10 times x gives me 10x. 10 times x gives me 10x. I get 10 plus 10, which is 20. 20x in the middle, right? So we always check whatever we put here. Is this, is whatever this and that, when I add them together, do I get back what's over here, But there it is. Now this one's easier. This one here, well, we look at this one, right? So guys, you look at this one with me. See this? I've got x and both terms, right? So I can just factor x out. I'm left with x here, plus 8. That's it. That's it for that one. Now this one down here, I don't know. We can try. How do you get a 9y squared? 3 and 3? Yeah, we can do 3y. I mean, there's other things you could do, though, isn't there?
9 and 1.
You could do 9 and 1. Yeah, you could do 9 and 1. Let's hope for 3 and 3 working, yeah? Listen, we'll try it. And if it doesn't work, then we'll try something else, right? To get a 4, I can do what? Like 4 times 1? 2 times 2? Now if I do 2 and 2, I'm only going to get 12 from that, because I'm going to get a 6 plus a 6, which is a 12. It's like 2 and 2 isn't going to work. I got to try the 1 and 4. So does that work? I don't know if it works or not. Let me try it out. 1 plus 4. So then think about it, right? This gives me 3y, and this gives me 12y. 3 plus 12 is 15. Got it. That is it, right there. Factored. Now, you notice in everything we've done so far, we have not needed what? We have not needed my completing the square method yet, right? These were just guess and checkable. Let me throw in a completing the square type example down here. Something like x squared plus 8x minus, 71. There, that's awful. So that's not going to factor. So I'm going to complete the square on this guy. So that gives me x minus 4 squared minus 16 minus 71. See, so what I did was I took half of 8. Half of 8 is 4, right? And I was not supposed to put a minus there, right? I should have put a what? I'm supposed to put a plus here because I got a plus over here. That was supposed to be plus 4. Okay. Now, if you think about that, x plus 4 squared gives me back x squared. Work it out here for a second. I got to work it. Let me put it something. Let me just write it out here. So like x plus 4 squared is x plus 4 times x plus 4, right? Which is x squared plus 4x plus 4x plus 16, which is x squared plus 8x plus 16, right? So this guy right here, x plus 4 squared, is this, which is literally all that. What do we have? We don't have all that, right? We've got only what to start with? We've only got this x squared plus 8x, right? So if I trade x squared plus 8x for x plus 4 squared, I'm actually adding 16 by writing that. So to be fair, I subtract 16. Now everything's even Steven. Is that something we say? I don't know. Who is Steven? I don't know. But minus 71. Now look at this. Well, this is x plus 4 squared, and 16 plus 71 is 87. So I got minus, use your imagination, square root of 87 squared. Now I've got the difference of squares. So I can go back to my difference of squares formula. This is x plus 4 minus the square root of 87. X plus 4 plus the square root of 87. There you go. Factored. Ugly, but factored. I don't think you'll find a problem like I just worked in the book. So to be fair to you guys, I'm going to add a couple of these on the review sheet to make sure that you have something to check yourself on. So I am making a slight course correction in terms of the next test. There will be a couple problems on there which were not in your homework exactly, but they are problems that we have done in class over and over again. And they will also appear on the review sheet. And it will also not be more than 10% of your test. Okay? So there's that. That's my plan. So there should be like 2 completing the square problems on the test is what I'm trying to say. There'll be 2 problems where you have to complete the square to solve it. However, I should point out, completing the square is always something you can do on a factoring problem.
I had a question.
Sure.
Is there any way I could get the sheet earlier?
Yeah, I'm hoping to have it like Friday. Yeah, hopefully Friday night I'll have it.
I gotta pass this.
I hear you.
I'm not really using no more classes because I really got in trouble by my advisor. He was like, "Kai, you know, you're not supposed to be missing no class."
Well, yeah, it gets lonely in here sometimes. It's not just you. Let's see here. So here are 5 examples of factoring. What I want to now do is look at 5 examples of solving equations. Okay? Solve the equation. And by that, what I really mean is find all of the solutions. So I don't want just one of the solutions. If there's 2 of them, I want you to find both of them. If there's no solutions, I want you to tell me no solutions. All right? So here's my example 6. Let's see if we can solve x squared plus 3x equals to 28. Okay, so if you're facing a problem like this, the first thing you want to do is to rewrite it as stuff equal to 0. So this is x squared plus 3x minus 28 equals to 0, right? Agree? Disagree? Agree. Look at example 1. X squared plus 3x minus 28 is equal to x minus 4 times x plus 7. See? So we can factor this to x minus 4 times x plus 7 equal to 0. And why do we do that? We do that because when we've got the product of 2 things equal to 0, that means that either this has to be 0 or that has to be 0, or they both have to be 0 in order to solve this equation.
Basically, x is going to be whatever number that can make them, that 4 and that 7 equal 0.
Right, so either we've got x minus 4 equal to 0, or we have to have x plus 7 equals to 0, right? Now, x plus 4 equal to 0 tells me what?
It should be positive 4.
Yeah, x is positive 4, or x is equal to negative 7, right? So if we can factor, well, first of all, if we can recognize it as setting a polynomial equal to 0, right? If we can take the equation we're given and we can rewrite it as a polynomial equal to 0, and then we can factor that polynomial, there's a straight path to finding the solution. We just look for where each one of the factors could be 0. But one of the things I'd like to point out, and you're going to get really tired of me pointing this out, but here it is. Example 1 and example 6 are different examples, right? The answer here was an expression, because when we factor, we take a polynomial and we rewrite it as another expression, right? The answer is not numbers. The answer is this formula. Here, we're solving this equation, so the answer will be a number or a pair of numbers. In this case, 4 and minus 7. They are very much related, right? But they're different.
One is a formula and one is
So one is, the answer to one is a pair of numbers. The answer to the, example to 6 has the answer is numbers. Example 1, the answer is an expression. So this is an expression. So I know I'm not, see, because there's just this ubiquitous confusion that happens with students in your place, where when I ask for factoring, I get a solution, and when I ask for a solution, I get factoring. And so it's important to understand what the difference is between factoring a polynomial and solving the polynomial equal to 0. They're related, yes, but they're different. Understanding that difference is part of this course. So example 7, I think you're probably going to get tired of this, but solve this equation, x squared plus 20x plus 100 equal to 0. So notice it's an equation. We're trying to solve it, right? But example 2, right? Example 2 helps, because example 2 already told me that I can factor this as x plus 10 squared equal to 0. Yeah, I should mention this can also be written as x plus 10 squared, right? Yeah, so I mean, sometimes we write it like that, sometimes we write it like that. I mean, whatever. But the point is, so what is the solution here? How can you get this to be 0? Right, exactly. X plus 10 has to be equal to 0, which tells me, just like you said, x equals to minus 10. And I think you're right. Once you understand what you're doing, like this middle step isn't really needed. Wait a minute, so this one just has one answer. Isn't that interesting? So this quadratic equation, this is, by the way, this is a quadratic equation. A quadratic equation could have 2 answers. It could just have 1 answer, right? We saw last class that sometimes they have no answers. Example 8. Let us see if we can solve x squared plus 8x equal to 0. Now we're dealing with an equation, right? Now it is related, of course, to example 3. Example 3 basically is the step I need to make to be able to see how to solve this equation, which is that this is x times x plus 8, right? So I can factor that equal to 0. And let's see here. So we're going to take the training wheels off. This says what? X equals to 0 or x equal to? Not 8, but negative 8. Do I need to put the training wheels back on? I might need to put training wheels back on. I don't know. So this is a very popular mistake. 8 appears here, right? But the question is not that is there an 8 there. The question is, what does it take for x to make this 0? It must be minus 8 to make that 0. That's why I put minus 8. Because the ultimate question here is, can you find a value for x that when you plug it into the equation, it makes the equation true? Okay. Example 9. I think you know where I'm going with this. Let's see here, where were we? 9y squared plus 15y plus 4 equals to 0. That looks kind of scary, doesn't it? But listen, there's nothing to be scared of here because we already learned in example 4, we can factor that expression. Right? So we can trade the equation that we're given for the much more simple equation, 3y plus 1 times 3y plus 4 equals to 0. This is a more simple equation because we can solve that by dividing and conquering, right? Either the first factor is 0 or the second factor is 0. Now I'm going to put the training wheels back on because it's healthy. So in other words, I'm going to solve either 3y plus 1 equals to 0, or I need to solve 3y plus 4 equals to 0. So what do we get there?
Is that gonna be like
It's going to be like what?
question?
Mm-hmm.
See, I was thinking it was gonna be like a fraction.
Yeah, it is. It is. So I'm just not there yet. So yeah, so that equal to 0, that equal to 0, right? But I need to solve for y. See, then 3y is minus 1, so therefore what? Y is minus 1/3. Yeah, minus 4 over 3. So you're right, they're fractions. Now, sometimes I am able to skip past the training wheels, as I called them here, and just like go straight from here to there. But I have to be careful. Like, I still make mistakes on that, despite the fact I've done nothing but math my entire adult life. I still will mess up on that if I'm not careful. As they say, pride goes before the fall, you know. Let's see here. Example 10. So you know what we're going to do? We're going to solve 8x. We're going to solve x squared plus 8x minus 71 equal to 0. So remember, this can be factored as x plus 4 minus the square root of 87, x plus 4 plus the square root of 87 equal to 0, right? So we got it, right? So here I'm using example 5, right? So what are my answers? My answers are a pair of numbers. I either have x is equal to minus 4 plus the square root of 87, or x is equal to minus 4 minus the square root of 87. So the more, like, my point in all this is these are factoring problems. The answer every time is an expression, right? These are equations. The answer is either a number or a pair of numbers. And it can also be possible that there's just no solution, no real solution. We saw that last class. So one more example for today, and then we'll be done. So there's some problems at the end of section 4.8 that have got like a little bit different structure to them. So let's see if we can unravel them. Let's see here. So so section 4.8, like number 47, for example. Here we have g of x is equal to 2x squared plus 5x. Okay, that's given. So you're given this formula for this function g, right? And then it says, here's the question. Find all values of x such that g of x equals to 12. So at first glance, this looks like a different problem than the ones we've solved already, right? So So we have to just kind of put it together. What's this mean? We've got, so there's g of x, right? 2x squared plus 5x, right? And we're trying to find x such that this is equal to 12. Ah, hey, that's a quadratic equation. Like, we know how to solve these. So what's our first order of business? We want to make everything equal to 0 because that's where factoring helps us, yeah? So we've got 2x squared plus 5x minus 12 equal to 0. So now what? Let's see here. Can I do maybe 2x on one, x on the other? 12. How does 12 factor? It's 1 times 12. It's 2 times 6. It's 3 times 4. I think them's your choices. I need to get a 5 in the middle. Here, I'll try one just at random. 2 and 6, yeah? I got to put a minus on one of them and a plus on the other, yeah? Well, that didn't work, right? Because I got minus 2x plus 12x. That gave me 10x. That's not going to do it. So I would try something else. What if I put a 3 here and a 4 here? How's that go? 2 times 4 is 8. Minus 8 minus 3, hey, that's 5. So there. So the logic here is, first of all, write the 2x and x down, right? And then we just look at 12 and look at how it factors, right? This either is 12 times 1, 2 times 6, or 3 times 4, right? And so then you got to make one of them plus and one of them minus because you got a minus 12. So either you're going to, like, your choices are essentially either to put 12 here and a minus 1 here, or to put minus 12 here and a 1 here, or to put a 2 here and a 6 here, minus 6 here, or a minus 2 and a 6 over here. Or you could do 6 and minus 2, or minus 6 and 2, or you could do 1 and minus 12, or you could do minus 1 and 12. I mean, there's a lot of different possibilities because these are different because there's a 2 here and there's not a 2. I mean, there's a lot of choices. We actually got kind of lucky in the sense that the second one I picked happened to work, right? But that's one way to do this. It's just by guessing, right? The other way, you could have completed the square. You could complete the square on this. Let me finish this way, though, first. So what are my solutions? My solution's either 2x minus 3 equals to 0, or x plus 4 equal to 0, right? So either x is equal to 3/2. Right. So there it is, right? Okay, so I think we agree that this factoring here was tricky, right? I mean, this could have gone wrong for you, right? So here's my fallback method. I factor the 2 out. I've got 2 times x squared plus 5/2 x minus 6. Complete the square. I get, and so I can, by the way, I can divide by 2. Now I can just divide by 2, right? Divide both sides by 2. So you got x plus 5/4 squared minus 25, minus 5 over 4 squared minus 6 equal to 0. Which we could write as x plus 5 over 4 squared equal to, let's see here, that's 25 over 16 And 6 in terms of 16ths, what's 6 times 16? I feel like it's 96, plus 96. Hmm, 121. By the way, that's 11 over 4 quantity squared. So then when you take the square root of both sides, you get x plus 5/4 equals plus or minus 11 over 4, which tells me x is equal to minus 5/4 plus 11/4, or minus 5/4 minus 11/4. Run out of board space, but if you work that out, what's 11 minus 5? 11 minus 5 is 6. What's 6/4? 6/4 is 3/2. Minus 5 minus 11 minus 16. Minus 16 over 4 minus 4, right? So that's this one. So the difference between what I did in yellow and what I did in white is what I did in yellow is clever. It requires proper guessing. There was like 12, there's a bunch of guesses. We got lucky that we got it on the second guess, right? This one down here was not luck. This is just, you complete the square. It's an algorithm. And yeah, the arithmetic gets a little bit dicey because it's got fractions and junk, but anyway, these are the two ways I know how to do it.
I think yellow will work more for me.
Yeah, that's all good. I mean, you don't have to do it the white way, for the most part. Anyway, see you guys Friday. Well, some of you.
I'm coming Friday.
Don't miss the student that comes all the time.
I'm not missing no more.